Hey, we have here today another integral on the board. This was from MIT Integration Bee 2022. This is from quarterfinals, round 4, problem 1. We have the integral of 0 to 1 minus x plus square root of 4 minus 3x squared over 2 dx. Okay, I definitely had a few questions and concerns on this one. And the interesting thing is, like, what is minus x over 2 doing here? I mean, we could split this into two integrals, and this is a very easy integral, but I just don't see what it adds to the problem. The integral is really all about this over here. I'm going to kind of just take like a brute force, straightforward approach to this. Let me know if you had some other ideas or a way to incorporate this. I didn't really have anything creative, so let me know what you came up with in the comments. Okay, so like I said, I'm really going to focus on just this second integral. I'll come back and integrate minus x over 2 later, but let's just focus on pulling the 1/2 out front and integrating 4 minus 3 x squared dx. And for this, I'm going to want to do a trig substitution. What I can do is I can write the 3 as square root of 3 squared here. So then what I'll do is make a substitution for square root of 3x. And I'm going to want to use sine, just because notice this is kind of like 1 minus x squared. So this is a good case to use sine in the trig substitution. But I want to match this 4, so what I'm going to do is put a 2 in front. And just to make this clear, let's notice what happens when we square both terms. So like on the left side, squaring this is going to be 3x squared. And then squaring this is going to be 4 sine squared t. And let me just isolate my x right here. So if we divide both sides by a square root of 3, we'll have 2 over square root of 3 sine t. And then I'll take my derivative to get a dx value. And this is going to give me 2 over square root of 3 cosine t dt. And one more thing real quick, I think I will just get a value for t. So if I divide by 2 here, what I can do is isolate this as arc sine of square root of 3 over 2x, just solving for t from this first equation. And now I'm ready to substitute, so we'll still have our half out front. I'll take a 1 and plug it in right here. Arc sine of square root of 3 over 2 is going to be just pi over 3. And then plugging a 0 in, arc sine of 0 is just 0. Then in here, we're going to have our 4 minus, now this is 3x squared, so we have this expression we found here, which is 4 sine squared t, and then our dx value is going to be this, which is 2 square root of 3 cosine t dt. Now from here, I just want to clean up this a little bit. Notice we can factor a 4 out of this, so I can write this as 4 times 1 minus sine squared t. Okay, but then we'll take the 4 outside of the square root, so this is going to come out as a 2, but I can cancel it with this 1/2 right here, so we just have a 1 out front now. But 1 minus sine squared t is the same thing as cosine squared t, but it's inside the square root, which is just going to give me cosine of t. So let me rewrite this. I'm going to bring my 2 square root of 3 out front. So let's clean this up a little bit. So we'll have 2 square root of 3 from 0 to pi over 3. Again, the square root of cosine squared t is just cosine times this other cosine is going to give me cosine squared t dt. Okay, now from here I'm going to do the standard thing on cosine squared, which is I'm just going to use the identity to reduce the power, which is going to allow me to write this. I can write this as half plus half cosine of 2t. Okay, now I'm just ready to integrate. So we'll keep our 2 square root of 3 here. So integral of a half right here is going to be just 1/2 t. Integral of cosine 2t is going to give me sine 2t. But then I need to bring out this 2 in the denominator, so we're going to write this as half times half, 1/4. And then we just need to evaluate this. I'm evaluating this from 0 to pi over 3. But just notice when I evaluate this at 0, the sine at 0 is 0, and t is going to be 0, so the whole thing's 0. So we really just need to plug in pi over 3 and rewrite this to finish it off. So we're going to have 2 square root of 3. We're going to have a half pi over 3 plus 1/4. Then plugging pi over 3 in here is going to give me sine at 2 pi over 3. Sine at 2 pi over 3 is going to be square root of 3 over 2. Just going to distribute in here. And so when I do that, these 2's are going to cancel. And this first term is going to be pi over 3 square root of 3. And then when I distribute into the second term, the square root of 3's are going to cancel. The 2's are going to cancel here. And we're just going to be left with this 1 over 4. And I kind of lied a little bit when I said we were finishing off, because we still have this integral here. We still have this minus x over 2 thing. So I'm going to write this. We're going to need to find the integral here of x over 2 from 0 to 1. Okay, so if we integrate this, we're going to get just x squared over 4. And we just need to evaluate this from 0 to 1. So plugging that in, plugging in a 1, we get 1/4. Plugging in 0, we get 0. So now to finish it off, we're going to have pi over 3 square root of 3 plus 1/4 here, minus 1/4 here. These cancel out, and so our solution is just going to be pi over 3 square root of 3. So that's it. Not too bad. Kind of just brute force. I know it's kind of a straightforward method. And again, just let me know in the comments if you had a different way. I'd be curious. I have no idea why they put this in here, but sometimes they just do that to throw you off a little bit. So I'll stop it there. Thanks everyone for watching today. Have a great day.